Hi everyone, nice to meet you. My name is Ho Young-wook from Midas IT. The purpose of this webinar is to explore the feature and tips of Midas Design Plus. In addition, by demonstrating Eurocode-based RC and steel modules, you can check the design report and generate a member list of design components. At first, I'd like to explain the procedure of Midas Design Plus. Midas Design Plus is the member unit design program optimized for structural engineers to design members and generate member lists quickly and efficiently. The first one to hope to introduce is about Midas Ring. Midas Design Plus can connect with our 3D analysis program, Midas Gen, and can import the section parameters, member forces, and load combination from Midas Gen. Secondly, I can combine the design and drawing generation for various structural members. It contains the latest international standards like Eurocode, ACI, AISG, and AA. It also provides FEM analysis in baseplate module and reinforcement module by externally bonded FRP system for strengthening concrete structure. After designing component, you can see two types of design result, detail and summary type. Lastly, various type of output. It can also sub to various types of output format like MS Word, Word RTF, Excel, libexcel, and text format. You can print a report by Word RTF and libexcel format. This format has faster performance than MS Word and MS Excel. To generate member list, DWG and DXF format for CAD drawing can support it. It is possible to check all this one by one program, Midas Design Plus. The user interface of Design Plus is composed as follows. This configuration proceeds in a flow from left to the right. The design options rotated in the left can be easily set in the workbar. Based on the set menu, you can enter specific data of the member to design, like material, section parameters, and member pose parameters presented in the code. Confirm a simple check. Next, after confirming the safety review of the checked member, the specific design result is presented in the form of report on the right. Let's take a closer look at the configuration of the user input interface. There are UI mode tab and Midas Ring tab on the top. The UI mode is the current working mode and consists of project and simple and check mode. If you want a simple design result and report generation, please select simple mode. The Midas Ring option is a function to link with Midas Gen, which will be explained in more detail later. The workbar is configured on the left, and the messages window is configured at the bottom. The workbar is used to when member name changes, grouping, report, and drawing export setup. And message window is to show various information, warning, and error messages. The top is the switch the warning working window between member list, drawing, and quantity. By using tab option, you can easily change these different working steps. And the report button here is correct. It can be generated input data, summary, and detailed design result report. The type of report are detailed, summary, and input data as described above. Also, it contains of input area and preview area. You can input the design data or forces automatically or manually in input area, and design or check results are displayed instantly in preview area. These are the design members and code supported by Midas Design Plus. The supported modules are RC, steel, SRC, aluminum, and reinforcement. In the case of reinforcement, it supports slabs and beams and column. And FRP reinforcement is possible according to ACI 440. Specific member modules are represented by icons. It is possible to design the overall architectural structural element, not only the main members, but the substructure members. Supported country code are American series, including Columbia, Eurocode, and Korean code. The design model of the Eurocode series have not been developed compared to the American code series. We'll do our best to develop it in the future. Before getting into the demonstration, I'd like to share the scope of this webinar. The scope of this webinar is about general section column, isolate footing, base plate, moment board connection module as per Eurocode. This module do not support design function in Midas Gen. Therefore, we plan to link Gen throughout Midas Ring and design this module in Design Plus together. So let's run about the Midas Ring option. Using Midas Ring option, Midas Gen can link with Midas Design Plus. Let's see how to use Midas Ring. First, click Midas Ring button, and second, select the Gen project to import and click the Connect button. If your connection is successful, the following message is displayed. Once connected, add the model you want to design and select members or nodes selected in Gen, and it will be automatically displayed in Design Plus like that. Ring option is useful when doing Midas Ring. Many users do not know this option, but it is useful to know how to use it. Among them, the road combination type option is very useful. Design Plus provides 5 different types of road combination. The first one is by Gen. It is based on the Gen analysis result. The absolute value gets the largest member force value. In this case, only one case of road combinations is imported. The second one is by all load combinations. By all load combinations of Gen are imported into the Midas Design Plus. In this case, the same number of load combinations of Gen is imported. And third one and the fourth one are by max and min force. When selected, get the load combination with maximum and minimum axial force, moment, and shear force. If you select by max min force selected, the largest and smallest member of force are selectively imported for each member force component. In this case, since max and min value are imported for each P, moment X and Y, shear X and Y, so 10 cases of load combinations are imported totally. Finally, by envelope. Like Gen's envelope function, only imported the largest value of axial and moment and shear force respectively. In this case, 4 cases of load combinations are inputted. Now I'll explain the general column section and isolate footing according to the Eurocode. First, RC general column design. Except for the rectangular and circular shapes of RC columns, all other shapes of columns are called general column section. This is input data of general column. Let's look at the tab section 1. Among the input data of the general column, I'd like to k-factor at first. K-factor means the scale factor of the column effective length. Depending on the condition at bottom end of the column, the k-factor can be set as shown this feature. K-factor range for greater than 0 to 2.1 in program. The next one is equivalent area for general section. For cross-section with symmetrical reinforcement loaded by the compression force, it is necessary to assume the minimum eccentricity. So equivalent dimension is for calculating eccentric moment due to imperfection as per Eurocode 2. If you click the Update Size button, the center of the general column is automatically calculated and the eccentric moment can be calculated. The following one is considering imperfection and second-order effect. This option is for considering moment magnification due to imperfection and second-order effect as per Eurocode 2. In Eurocode 2, 0.7 for A, 1.1 for B, and 0.7 for C are alternate and recommended value. And if you click the blank like that, the program will calculate the various values automatically. Lambda is the slenderness ratio of the column. If lambda value of the column is below the lambda limit, the secondary order effect may be ignored. The next content is about importing section from CAD and SEC file. The SEC file is made by Midas SPC program. The shape of rebar layout of general columns can be imported as CAD file or SEC file. First, select the CAD file or SEC file and click the Import button. And the general column information of the already saved CAD file is previewed. The shapes move to the section layer and the rebar move to the rebar layers. And if you press the OK button and the CAD file data is input the Design Plus. The next topic is RC isolate footing design as for Eurocode 2. The isolate footing support mat type and pile type. Let's see the input data of isolate footing. Look at the tab section 1. In designing isolate footing, load combination of member force is divided into serviceability limit state and ultimate limit state ULS. In SLS load combination, it is related to footing side in mat type. If soil bearing check is NG, you should increase the size of footing. In pile type, it is related to pile number. If pile capacity check is NG, it needs to increase the number of piles. In ULS load combination, it is related to fractional and shear design of footing. If bending moment check is NG, reinforcement rebar is needed, and if shear check is NG, you should increase the depth of footing. Third one is about surcharge load. The surcharge load is divided into surface load and soil load. The surface load is a kind of a live load added to the upper face of the footing, and soil load is multiplied as weight of density and height. The following one is the input data of tab section 2. You can define the footing size and soil and pile capacity. Footing cover is a clear concrete cover in depth. In general, 80 mm for mat footing and 150 mm for pile footing, taking into account the pile tabs. Number 5, column section. EX and EY define the position of eccentricity when the center of the column and the footing is different. When eccentricity acts, an additional moment force is generated, which is reflected the flexural design of footing. Finally, soil bearing and pile capacity. The soil bearing value is the allowable bearing capacity, and pile capacity of value is also the allowable value. This value should be confirmed by geotechnical engineers. Next, I do demonstration of RC structure for designing general columns and isolate footing. So now let's get into the demonstration. Let's run Midas Gen program. In new version of Gen, you can easily open files you have recently worked on. Click RC demo, and the file has been opened. As you look at the worktree menu, section ID 1 and section ID 2 are defined as general columns. And let's check the load combinations. Strength combinations are defined from number 1 to number 17, and the substability combinations are defined from number 18 to number 32. And check the concrete materials. It defined as C2025 over Eurocode 04. Then rebar materials as well will set class B of Eurocode 04. Also, let's look at the concrete design code. It's defined as Eurocode 2. Okay. We also check the support conditions. It defined well. So let's analyze the model file. The analysis is completed. Okay, then let's target the members you wanted to import. Section ID number 1 and number 2. General column for design general section column. And C1, 2, C2, 3 is support for isolate footing. Then open the Design Plus program. Let's set the design code and Riva code to be the same as Jan. It doesn't matter if you set it later. Okay. And click Midas Ring. Select Midas Gen to be linked with Midas Design Plus. Then click Connect button. Successfully linked. Then excuse general column from RC category. Click Add button. Click to link option and change the road combination type to by all road combinations and click OK. Shift to the gen and select the desired general column element to be then imported to Design Plus. Select section ID 1 from the worktree bar and member number to be imported are displayed in this blanket. Click Import button. And the general column 1 has been imported to the member list. Then we will also import the general column 2. This time we will change the road combination type as by max, min, or. Okay, let's look at imported member name. 1 to 3 means the story name, and the next text means the section name, and the number of this bracket means first number of its section's ID. And set kx and ky to 0.5. And check the number of main bar and rear bar diameter and click check button. Since there are 408 road combinations to check it, so it takes some time to design. Check the design result. The ranges in actual force and moment check and spacing of hoop bars. So increase the number of main bars and decrease the spacing of the hoop bar. And check again. All checking is okay. So let's also check the general column 2. Since there are 10 case of road combinations, the design time is faster. Let's just decrease the hoop spacing, or it's okay. In report, we'll introduce the user unit system. If you press report option button, you can see the unit system. The default one is design code unit. For Eurocode, it follows the SI unit system. If unchecked, the user unit system can be selected. I'll change it in kips and inch unit. All formulas calculated in the left have been changed in kips and inches. Okay, let's check the design result. And go to the Memories tab and check the design results of the designed general column. And the design report has Word, Excel, LibXL, and text format. Among them, were generated in Word format. The Word program is often then to show the design result like that. Okay, then let's see how to generate CAD file for memories. Go to the Drawing tab and you can check it by selecting RC column general and press create button. You can see the memory list of general columns. To save the CAD file, press the Save As button. Let's save it as DWG format file. Okay, next demo is for isolate footing design. This is similar to general column method. Select nodes and add to activate the footing module. Shift to the Midas chain. We will select nodes under the column C1, C2, C3 to import them. First, we will check if the footing design of C2 column is met type. There is an engine in the soil capacity check. Let's increase the size of footing. So there is an engines. So increase the depth of the footing and when you see the maximum rebar spacing is 400 millimeter, we'll decrease the spacing. Now or is okay. We also check the footing design of C3 and C1. Let's check C3 footing design as pile type. Increase the depth of the footing, change the cover, and press check. There is a two-way shear engine, so increase the depth of the footing size. So or is okay. But the tail result, there is a spacing engine, so the decrease the spacing of the rebar space. So or is okay. Let's check the C1. There's many engines of design results. So let's use the design function. Go to the RC1 and press the change in section by design and click the design button, and footing depth, size, and rebar data are changed by section. Change the rebar space to 200 millimeter. Increase the depth of the footing. Increase the footing size. and all is okay. All designs are complete. So you can print design report in the same way. In this time, I print the word summary result. It generated summary report. Okay, and go to the drawing tabs and change the RC footing and create. There are two types of member list format, meta type and file type. If you click the print list button and select the frame, you can check the output immediately. The member list of the RC footing is successful. Okay, this is the end of the demonstration of RC structure. Now let's explain the steel relative module according to Eurocode 3. First, the steel base plate design. Let's see the input data of base plate module. Let's look at the tab section 1. First, select design method. Design Plus support the effective area method based on the equivalent T-stop by the EC3 code. In addition, the finite element method using the program by solver is also provided. For exact result, you can go with the effective area method as it is totally code-based. The FEM is supported to use for non-standard configurations of anchor bolts and sections where EAM is not applicable. If you choose effective area method, rib and wing plate can't be used. The second setting I can explain is the bearing resistance factor, AB. The bearing resistance factor AB is a factor for calculating the bearing resistance strength FBRD. According to Eurocode, AB entered the smallest value among the following three values and must be calculated manually. The default value of AB is 1.0 in program. Look at the tab section 2 of the right side. This figure is for detail of base plate. Number 1. Anchor length. Anchor length is multiplied as inputted value and anchor diameters. Number 2. Position of x direction. Number 3. Position of y direction. Number 4. Number of x direction. And number 5. Number of y direction. This corresponds to the layout of anchor bolt. Lastly, if placed on pedestal, check this button to define the size of pedestal. This is tab section 3. As I explained, this tab is only active for the FEM method. When check on the option for use rib plate can be defined. This figure is a detail of rib plate. Number 1. Thickness of rib plate, height of first row and height of second row, and length of first row and length of second row, and the number of rib plate. Next module is steel moment bolt design. Let's look at the input data of a moment bolt connection. Let's take a look at the girder tab. The first selection is about the number of girders. Support single and double girder type. The second one is input angle of girder. In the case of gable roof or inclined beam member, enter the angle with the column. The default value is 0 degree. The third one is inputting reg ranks. As you can see, you can input the reg ranks of the web and the flange side of the welding side. At this time, the throat thickness is calculated by the following formula. Throat thickness cannot exceed thickness of webs and flange. Please look at the right side. The number 4 is about calculation of reduction factor, KWC. KWC is determined by equation 6.14 of Eurocode-3, and it is a factor related to column webs in transverse compression. The program can calculate KWC from the input compressive stress and member force automatically. Next tab is about bracket. If you check use bracket, you can use bracket design. Generally, the section of bracket is same as the section of gutter. The reg ranks of initial value is the same value as the reg rank set in the gutter tab. This figure is about size of bracket. You define ranks, height 1 and height 2 of the bracket. Let's look at the right side. If you check use stiffener, you can use stiffener design. There are many kinds of stiffener, but the program supports the detail of installed on the side of the column webs as shown in this figure. This figure is a detail of stiffener. The stiffener can be installed on 3 parts of position: top flange, bottom flange, and column web. Width of flange web is here, and the corner width is here. And the width of the column web is here, and the height of the column web is here. You can also define the number of column web here. These are size number 1 and size number 2. Finally, let's look at the bolt layout. There are 2 options determined by program and specified manually of shear load designation. The shear load is related to vertical shear resistance check. If you select specify manually, the design shear resistance VRD is calculated as a sum of bolt in shear for bolt number of bottom and the effective shear resistance for bolt number of top. This figure is about bolt layout. Here, you define the number of top bolts for tension and the number of bottom bolts for shear. Also, number 1, extension horizontal, and number 2, extension of top, and number 3, extension of bottom, and number 4, spacing of horizontal, number 5, spacing of vertical, and number 6, offset ranks. Lastly, considering gutter web thickness. If you click this option, the width and end plate will be modified as a sum of spacing of horizontal and the web thickness of the gutter. It finished the examination of the input data of steel module. Then, we will demonstrate the steel structure. Okay, let's get into the demonstration. Let's run Midas Ring program and click Steel Demo. You can easily open files you have recently worked on, and we will check the model first. We will check the material property. It is set as S235 of Eurocode. Okay. Next, we will check the support condition. There are all pins supported. Okay. Oops. Sorry. We also check the steel design code Eurocode 305. Okay. And we will check the road combination, the steel design. There are 17 cases of road combination for strength road combination, and the rest is the subsibility road combination. Okay, let's do the analysis. Okay, analysis is finished. Let's target the member you want to import. Section ID 1 and 2, column for designing base plate, and the moment port connection where the column members and the gutter members are connected. There are 6.6 connections, and the it is a wire brace. It is a vertical brace, the opposite side of the structure. So we need to consider the wire brace to designing moment board connection. Okay, let's run the design plus and press new project. Okay, and then let's set the design code and steel code to be the same as Gen Eurocode 305. Apply and change the material DB. The material DB is EN. Yes, and section DB is Unicode. Okay, and unit system changed as SI unit. Okay, the section DB is changed. Okay, and we will do the Midas Ring. Press the Gen project and press connect button. Is successful link with Gen program. Okay, then we ship to the Gen and select nodes to designing base plate and ship to the design plus and execute the design base plate module and start the base plate module like that. Okay, and there is imported nodes to designing base plate and press ring option and change the road combination type as by all road combinations. Okay, and let's do to ring. There are two types of member list, SC1 and SC2. We delete the default one, and in this case, SC1 for base plate using the design method as equivalent T-stop method, and we set bearing resistance factor as 1.0. Okay, and go to the tab section 2, and we adjust the height, size of the base plate for construction, workability, 450 millimeters, and change the thickness of base plate for as 9 millimeter. Okay, let's check the SC1 base plate, or check OK, and then go to the SC2, and we'll do FBM method for design method. Go to the section 1, and the bearing resistance factor as 1.0, and go to the section 2, and change the height of base plate size 400, and change the thickness of base plate, and then we will check the result. There are edges for base plate, moment X and moment Y, so we will use the lead plate. We're designing lead plate, and thickness of lead plate is 12 millimeter, and height change 150, and the number of lead plate is 2 by 2. Okay, let's do check again. Okay, our check is okay. So I do it as member list for SC1 and SC2 for base plate. Go to the member list and click the R button and click the report. In this case, I do generate Excel summary. As I explained, uh, explained, as I previously explained, it will take some time to generate Excel. Yes, for SC1 and SC2 of base plate result will be generated like that. In this case, I will generate the RIB Excel for detailed calculation. There's a short time to generate. Okay, the SC1 and SC2 of detailed calculation report will generate it like that. Go to drawing tab and change the steel and base plate, and press the create button. This is the memory store base plate of SC1 and SC2. Okay. Now on, next is for moment board connection module. Select the beam column connect and we'll import them. Add moment board connection module and create a new model, and you check the member of the beam, and in this case load combination type is by all load combination. OK, and press import button. There are 6 deleted, and there are 6 types of connections totally, and as you can see 11 is the beam's number, and /1 is the column number. So this is column 2, and this is column 1, and this is beam 11. So you can find where is the connection position. Okay, let's set the Godard tab. Press check or yes, you can see the warning message. There is no setting. It is reg length, so we add the values here. Okay, the result is ng in moment resistance. In this case, we can increase the reg length, but I will use bracket. So yes, or checking is okay. However, as I previously explained, there are vertical brace. So the for working condition, the bracket type is changed to plate. So we choose the thickness value as 1 and check again, and the hunch flange is ng, so we change the reg length of webs like this. Check again, and all checking is okay. Let's do again. Connection 11/2. We define as reg length and use bracket, and in this case also plate use, and we use the thickness of plate, the 10mm. Also okay. We'll check again the another columns and other gutters. In this case, there is no word brace, so we will do H section using brackets. So we use type H section, and the setting is okay and press the check. The all checking is okay. The same way to the another opposite connection. Okay, bracket. Also use bracket and check again. Or check is okay. And the last part of the connection, there are also have the word race. So we use bracket as plate type. Okay, plate. And the thickness of plate is 10 millimeters and the reg range is 7 and range 10 and the once range is not okay, so we change the reg ranks. Okay, and the opposite mm, connections also change as the plate. Okay, our checking is good and I'll do it as memberist and press power button, and in this case we generate word and detail. Okay, the successfully generated. Okay, and go to the drawing tab and you can check the moment board connection and create button. You can see the memory store board connection. Okay. Okay, it's all for presentation. Thank you for your listening. So right now we'll go to the question step. I'm Ho, which is a technical software engineer in structural analysis of Midas IT. I'll be here to answer the question. Thank you.